Good morning, good afternoon, good evening. Thank you for joining us today. I'm Miguel Mendez, marketing specialist here at Unravel Data. And before we get started, there are three housekeeping reminders that I would like to cover. The first is, throughout the webinar, please drop your questions into the question box, and we'll do our best to answer them live or respond via email if we're short on time. If you submit one of the top 10 questions during this event as ranked by one of our fantastic panelists, you'll earn some cool Unravel swag. Additionally, this webinar will be available instantly on demand to listen to at your leisure, so feel free to pause or replay as needed. And lastly, help us improve. Share your feedback on the session by rating this webinar, and let us know if there are any other topics you'd like to hear about. All right, that covers it. So with the reminders out of the way, the floor is all yours.
Thank you. My name is Hal Schreiber, and I am a senior solutions engineer here at Unravel Data. I've been working with Unravel for about 8 months now, but I'm no stranger to the data space with several years under my belt and over 2 decades in a pre-sales engineering role. Unravel is a data ops and FinOps industry-leading actionability platform built for modern data stacks like Snowflake. Today's topic is going to be about evaluating costs in Snowflake overall for KPIs for cost management. More specifically, I'm going to walk you through some best practices on tracking costs defined by the FinOps Foundation, the leading organization comprised of some of the biggest data consumers in the world. Then I'll walk you through how these customers are using these tools available to them today to track costs in their data platform. And finally, how Unravel, the actionability platform built specifically for Snowflake use cases, can make it even simpler to automate these best practices. So let's dive in. A bit on the history of the FinOps Foundation. It was launched in 2019, where the FinOps Foundation addresses cloud cost management by fostering a collaboration across engineering, finance, and business teams. They joined the Linux Foundation a year later in 2020, and now it offers standards, certifications, and a community-driven approach, guiding global companies like Adobe, AT&T, and Spotify in adopting FinOps practices, including Unravel. A key methodology in this concept of FinOps phases, and there's going to be 3 of them. The first one here is inform. This phase is about gaining visibility into cloud costs. It includes allocating costs to specific teams or projects, setting up real-time reporting, and establishing key performance indicators for cloud usage. It empowers teams to understand and track their cloud spend accurately. Next up, optimize. When organizations get to this phase, the focus then shifts to efficiency. Now that we have an idea in the informed stage where costs are being driven, was it a particular user? Was it a particular project of a cost center? And now we're starting to get that information in. Optimize is all about the efficiency. Teams working on reducing waste, managing unused resources, and making cost-effective changes. Things such as knowing when to use reserved instances at the cloud level, or maybe picking the right compute types or t-shirt sizes that are sized for the particular workloads themselves. Or even going deeper into the code and looking for some fine-tuning of that code to maximize for efficiency. These are what the teams do during the optimize stage, and the goal is to maximize cloud value while minimizing unnecessary costs. Lastly, but not least, governing or operate stage. This phase emphasizes ongoing management and collaboration. So now that we know where the cost is being inflated, now that we've identified ways to optimize this, now let's make sure that we are operating on it. So teams establish governance processes that they leverage continuously, monitoring spending, and then refining their FinOps practices based on usage and budget trends. And you don't just stop at this governance stage. All of this is a continuous sort of life cycle, which involves regular communication between finance, engineering, operations to ensure financial accountability. Snowflake customers today are applying these best practices with out-of-the-box tools provided by Snowflake itself. So let's actually walk through some of this with you today. Okay, on the Snowflake side, there are native out-of-the-box tools, things such as account usage views, information schema views. These are sometimes referred to as systems tables, as well as a cost management dashboard tool. And these do a great job of providing some informational benefits, specifically some good cost visibility at that warehouse level, some account usage insights into the query history, warehouse usage and storage, as well as database and table usage metrics. This really allows organizations to track and analyze consumption patterns. They also open up some interesting use cases from an optimization standpoint. So now that we've got all this data about the warehouses, what can we do with it? Now we can monitor rather for warehouse usage. We can monitor for query performance and query execution. This is where a subject matter expert can come in to help identify efficiencies and optimize resource allocation on this cost front. What we can also do too is to start to facilitate the attribution of costs to specific teams or projects or users, enhancing financial accountability and supporting really that chargeback model mechanisms. Now, all this sounds great, but there's always a few gotchas. For one, these tools have a myopic system level view, and Snowflake is good at showing costs at that system level. But in my experience, folks really want things at a more granular user level view. Who actually touched this? How long are their queries running for? Were these users bridging across different data application cost centers? Things like that. And then there's the cost management dashboard. It does visualize some usage and cost trends and includes budgets and some alerting functionality for overspending. And there is the concept of what's called Snowflake object tagging at that warehouse level for some help here, but only if the organizations are actually applying and using those tags appropriately. If so, you can attribute costs to specific departments or projects utilizing this tool. There are also some gotchas here. While it shows us those costs from the system level on those things, what it does lack is that there is this limitation in that it's not real time. We don't really have that real time visibility in giving you the granular details. And if I wanted to understand at the user and query level and tie those back to department and project levels. So a lot of manual effort and actual combining some different data sets together would be needed to be able to get this information. So being able to get that full picture from a cost perspective, and if you're looking at or for rather a true chargeback scenario to understand more structured and granular cost consumption truths, then it's a challenge because you're only getting a partial view if you're just using a cost management dashboard. There's also a bit of a gap between that dashboard and the Snowflake system tables to correlate that table across those. So on that optimization front, what it does allow subject matter experts to analyze is the data. There's some manual effort to be able to first not only understand this influx of data, but being able to decipher it and identify areas of inefficiencies and then root cause it. If you have some Snowflake experts in-house, some SQL experts, that can help you immensely, right? Then you can really optimize from that standpoint. But if you don't, you're going to have to learn on the fly. And I've gone on this path with customers who thought that, hey, this would work, but in the end, it's not sustainable nor scalable as the data estates grow and the teams themselves grow. They've tried it. It leads to disproportions from a productivity standpoint and consequently impacts costs related to long mean time to resolution or troubleshooting, which pulls those experts away from what they should be focusing on, which is developing and bringing to market faster those data apps and data products. Last but not least, it doesn't necessarily or really effectively provide ways to operationalize or govern this from a bad behavior perspective. So while we can manually identify areas for optimization, how do you make sure that you are setting up best practices and ensuring that all of your users across the board are applying some of these best practices, in turn ensuring or making sure that they're making the right choices to be more efficient? It doesn't have these features and functionality out of the box, unfortunately, but other than that, still very useful tools, tables and dashboards from Snowflake. And we encourage customers to use all of these if you're not doing so already today. So to recap how these tools compare for FinOps specific use cases, if we take that inform stage, Snowflake account usage and information schema views, along with the cost management dashboard, if we combine those, provide some really good insights into query history, warehouse usage, and offer some table and database level usage information with visualizations around some cost trends. But the focus is only on that system level. There's limited real-time visibility. There's some lacking around tagging capabilities for specific projects and departments for that detailed breakdown. If I were wanting true chargeback and showback capabilities, you don't get that out of the box. Now, when it comes to that optimize phase, that second phase, Snowflake does a good job at highlighting high cost queries, warehouse overuse, and some storage growth metrics, which gives you a basis to identify those optimization opportunities. But it's manual. There's limited resources that can actually do this work and find these inefficiencies. There's no real automation around right sizing or other cost savings actions. And there's a requirement to leverage external tools for that active optimization. Last but not least, there's the operate/govern phase. Snowflake offers some governance data, such as metering history for consumption monitoring, but really lacks any policy enforcement or automatic monitoring and integration with those budgeting processes. There's a requirement here also for additional tools for continuous governance and optimization. Now what I'm going to do next here is I'm going to walk you through how FinOps teams are automating these best practices from that inform stage, from optimizing and from operating with a platform like Unravel. So what you're seeing here now is Unravel Data Actionability Platform, specifically in this case for Snowflake. We're going to start here at this cost tab, which is all about providing granular details and visibility into cost. More specifically, I'm going to be focusing on some, if not all of these sub-tabs here. So right now we're focused on the overview section. You'll see some familiar metrics that you might find in the Snowflake UI, such as total cost and total Snowflake credits consumed, some total cost breakdown across data storage and compute, and some trending graphs around consumption. Next, I'm going to jump over here to this warehouse tab. And again, some familiar metrics information around the compute cost breakdown and trends. So things such as virtual warehouses and the cost there, cloud services costs, serverless features if they're implemented, total virtual warehouses in terms of a US dollar cost, total number of those, and an average cost per warehouse. We also have a dashboard for most expensive warehouses and who those offenders are, who those top offenders are, with some other cost and consumption trending graphs here as well. And also in the left-hand corner, a breakdown in terms of the percentage that those warehouses are occupying across the Snowflake estate. Okay, now I'm going to jump back over here to this user tab, the user level. Okay, so here's where things really get more interesting. So again, with this dashboard, we get to see things like total number of users and the average query cost per user. The top users or top offenders in terms of query costs, some estimation around chargeback per user as well. So I'm just going to take a quick second here, and I would just like to encourage the audience to maybe reflect on how you are or how you are planning to do this today, this type of granular breakdown with respect to your Snowflake environment. Is it currently just something that you need at a warehouse level? Are there use cases and are you granular enough to look at it from that user level perspective, or maybe even the query level perspective? We'll get to this in a second. When I talk to a lot of our customers about FinOps use cases around cost observability and usage statistics, a lot of them are looking at things at that data product level. So in their case, it's sometimes more useful to track at that user level here, like I'm displaying, because those users span multiple products. They span multiple teams, multiple data apps that they're working on. And our experience here at Unravel has been that it's usually always the case with our customers. And so this resonates a bit. To that end, before I touch on queries, I want to talk about tags. This is a great place to see chargeback and cost trends by warehouse tagging, which kind of does meet that criteria requirement I just outlined above. So again, from that informed stage or phase rather, through the FinOps lens, this is where some of those gaps in being able to support details around cost allocation for specific business groupings and other business mappings to departments, maybe through this tagging, are being filled in. Now, last, under this cost tab, we come to the query level. So in a hierarchy of things, we've seen at the warehouse level and a bit more granular with users. We touched on tags and how those are useful. But now, at the end of the day, what are users doing? They're running queries against the warehouse. And this is where we can really drill into that level. So like the other dashboards, you have things like total queries and average cost per query. And there's some trending graphs as well. But also there's this query signature. Most expensive query signatures. What that is essentially is just a grouping of specific query text. So select star, insert into things of that nature. For example, I can come down here in the lower left corner to this cost charge back by query signatures. So my top 10 queries, top 10 most expensive query signatures, and I can hover over these guys and see exactly what percentage of my Snowflake bill these guys are consuming. So in this case, in my demo environment, 2.47%. And the next guy, probably something similar, 2.44%. And then there's some other trending related to those signature costs. Now, this is all well and good at a granular level, right? Which is important to satisfy that first phase, that informed phase of the FinOps best practices. But it's also important. I want to now take a step back and zoom out a bit. And I'm going to now click on this Home tab up here. And what you're looking at here is more of an executive level view. We've spoke at that query level, and that's pretty granular. But again, because we're talking here from the context of that FinOps best practice or practices, it's really important to get that bigger picture, that 10,000-foot bird's eye view of what's going on. And it's a little different design here, but I'll walk you through it. It's where we get a glimpse into the health of the environment. Only here we're doing a few different things. So across the top, you have your all-in cost, total in US dollars, right? Across all of the accounts, if we're monitoring multiples of those, an annualized projected cost based on that, and then the breakdowns across compute and storage and data transfer with the associated Snowflake credits consumed. From a compute standpoint, how many warehouses are we monitoring? How many queries? We have over 240,000 queries here. From a storage standpoint, hey, we got over 160,000 tables, and what's the average storage size on a daily basis during this period of time? Again, number of users, how many accounts that we are looking at. So the other thing we want to do here, though, is bring your attention to the three most important things that Unravel does. And all of these coincide with the FinOps best practices, those being increase productivity, improve upon performance, and ultimately reduce cost wastage. Here, we continue to inform around specific areas for potential improvement. But let's dive into the optimization side of the FinOps equation and see where really the rubber meets the road. So through Unravel's purpose-built AI engine, which has been developed and perfected and is constantly being developed over the past several years, we observe and then analyze how warehouses and queries run and perform over time. And then we can give meaningful insights and recommendations. These recommendations, when put into practice, not only provide an increase in productivity and performance, but give us a projected annualized savings across Snowflake estates. So, for example, warehouses. I have 47% of my warehouses, so that's 17 warehouses. Don't forget we had 36 of them that we're observing here. So 17 of those have some insights analysis. They have some sort of underutilization or some sort of wasted cost, and we want to be able to rectify that. We've got 14% of our queries to the tune of over 34,000 queries. Remember, we had over 240,000 queries that we are observing here, but that percentage has some sort of insight, some sort of efficiency or inefficiency rather, that can be course corrected through our recommendations. 82% of tables, over 132,000 tables, have some sort of insights analysis related to them. And then an extrapolation of across warehouses and tables and those queries, what is the projected annualized savings and what percent of the total savings is represented by those categories? We can improve performance over those warehouses and queries to the tune of 22% improved utilization for those warehouses if we apply the recommendations, and 16% faster on average query performance. So a lot of good information here, right? But let's again start to dig into the specific warehouse side here and the optimization piece of this. So as I scroll down to the bottom of the page here, and you're just kind of taking a look at some of these things here, what are we looking at here? Well, first of all, let's talk about the different ways to scale warehouses in Snowflake. First, we have the t-shirt sizes, right? The more commonly referred to as the scale-up architecture. Hey, I have a large warehouse, which gives me 16 cores and 64 gigs of RAM. There's mediums, smalls, extra smalls, maybe something that gives me something smaller, 8 cores and 2 gigs. This is where I'm thinking about, if I'm a developer, I'm thinking about my workload, running my heaviest workloads maybe. I need a lot of memory, CPU, because I'm servicing my heaviest queries. A developer, especially an experienced one, if given the option, will always pick the beefiest, biggest t-shirt size, but might not always need all of those resources. Or there's scale out architecture. Auto scaling comes into play here, right? I start out with a single extra small warehouse, and now over time, that got ramped up automatically through auto scaling to 10 extra smalls. This is our classic concurrency use case, right? How many users at once do I expect to service? This is the retail store during the Christmas season example, or the 9 a.m. to 5 p.m. Operations where I have my heaviest user count, but at night, fewer, not so many, right? So keeping that in mind, let's talk about the direct support for automated right sizing and consolidation that Unravel provides here. I'll start at the bottom. Warehouses with minimum and maximum cluster recommendations. These are warehouses that have recommendations for a minimum cluster number, right, for the cluster to reduce wastage, and or for a maximum cluster count to improve performance. Untapped savings related to what we're observing, and untapped on average, speed up of the performance of those warehouses. And we can see what those are here. From an underutilization standpoint, the workloads running on the warehouses don't fully utilize the extent of the resources available there, right? Therefore, these workloads can run on a smaller or cheaper warehouse without performance degradation. And then some wasted cost and untapped savings from an annualized perspective. So let's take a look at some of these. Consolidating warehouses. Here's the top 5 warehouses that we observed where if all of these warehouses, which were underutilized, were rolled into a single 4x large, we have over $500,000 in annualized savings. Now, right sizing warehouses. In terms of all of our recommendations, right, including consolidation, we take into account a lot of information. Idle time, is it a virtual warehouse? All this telemetry data. We take all these things into consideration. The algorithm, right, the AI, will take all of these things, it'll look at it, and all we're saying is, did you really need that size of a warehouse? If the answer is no, then let's make this simple change. It equates to less spend. Very simple. So let's walk through this. Here are some opportunities for right sizing warehouses. 5 of them. We'll just click through the top one as an example. Okay. So let's walk through this. What are you looking at? This is actually a recommendation in the form of a schedule. So gray and green. Days of the week across the top and hours in the day off to the left here. The current configuration is in gray. So this person, this group, whatever, shows a 5x large for the entire week and for every hour of the day, as you can see. Now, what we're suggesting is in the green. And sometimes we're saying, yeah, you needed the 5x large. It's warranted. We looked at it. We looked at the performance. We looked at what was running against the warehouse and the resources and how they're being consumed. And we concurred. This makes sense. However, moving out into the week on Tuesday here, at certain times of the day, we're recommending to change the t-shirt size to be able to realize some cost savings. We're saying between 11 a.m. and 3 p.m. And these other times, drop it down to a 4x large. You don't always need that 5x large. And so if you were to follow the schedule here, there is an annualized savings of over 100 grand. And we make it very simple for you, easy button style, right? Apply recommendations, one click. There's some code behind this, right? Here's the code. We actually give it to you. But one-click optimization from that standpoint. Obviously, there's some other processes and considerations to think about around this, but we make it that simple for you. Okay, now you might be thinking, hey, Hal, we already do node downsizing. I don't know about this. That's cool. Let me just mentally take you through the process again, right? Because I go through this exercise with my customers all the time. I usually go something like this. In order to do this, I need some time with the team. Let's say it's the data scientist team. I got to find and pull all the data into a model, do some analysis against it, and Oh yeah, because it's the data science team, we can only do this once a month. It works though for me, but I gotta wait until the 15th. But guess what? Today's the 1st of the month, and the higher ups are already making noise about the last month's Snowflake bill. So what do you do in that situation? The point being, it's a process. It involves resources, right? Whose time is finite. And by the way, who are human, right? Make mistakes. Let us be your expert in a box. That's what we want to do. And by the way, a machine, right, doesn't sleep. The AI I'm referring to, it doesn't sleep. It'll beat a human all day, every day, all the time, right? It won't get tired. It won't make mistakes. Let Unravel do the hard work for you, and thereby unburdening your staff, your engineers, your developers to focus on innovating. Okay, let's take another optimization example. But this time, let's look at the query page, the Query Insights Analyst page. And this is going to provide us some cost efficiencies. So here, just to recap, right, we have, remember, over 240 queries. Here's that number, of which we have over 34,000 that have insights. This is over a 7-day observation period. So I'm sure some of you have a lot more in your organizations. That's a lot. I couldn't imagine having to coordinate the manual effort needed to review that many queries, right? But again, here we're saying there's that 14% that we need you to just focus in and look at. We already did the work. The Unravel AI engine flagged these for some inefficiency, right? Where there's an opportunity to improve their performance and cost efficiency, right? Now you can also see here there's several impact categories. And so I'll just walk through these pretty quickly. Single row inserts, projection inefficiency, it returns a large number of columns, SQL anti-patterns, join inefficiency, also known as a Cartesian product, perhaps, an explosion of data. All things that we know are inefficiencies, but sometimes they happen. Sometimes there's business needs for them, but we want to bring them to your attention so that you can take a look at them and decide whether or not to perform some action. So an untapped savings related to all of those inefficient queries, the annualized untapped savings, the on average 16% faster performance for the queries with the insights. Obviously, should the recommendations be put into practice. And here's the top 5 most expensive queries that have insights and their number of runs. Failed and timed out queries. Also another area of focus to rein back in some wasted spend, right? Some wasted cost. In the last 7 days, there's a few grand here that we could get back, right? Here's the annualized roll-up of that. And the recommendations are around queries that failed due to some sort of complication, a runtime error, maybe it just timed out. But here they are, and they're available for troubleshooting. Maybe also moving these queries to a larger warehouse so that they perform better. Okay, let's dive into one example here. We have some time. I think let's go into join inefficiencies. I'm going to make a couple of selections here. Again, avoiding cross joins. Let me just sort a few things here. Okay. Again, Cartesian products, an explosion of data. It's something that we want to avoid, right? Unnecessarily. There might be a business driver or need for it, but we want to call it out. We want to flag it. I'm going to dive into this query detail page. And here I can see the estimated cost in terms of dollars and Snowflake credits. It was a successful in its runtime, total duration. Here's my user, the warehouse t-shirt size, number of bytes scanned, rows affected, and bytes written, 1.2 gigs. Okay, so let's expand these efficiencies. Actually, I found a couple here. Here's, not only did it find that you should avoid cross joins as an inefficiency in terms of the code, but also it saw a usage of functions and predicate, which is also another one of our efficiencies that we look at. But let's focus on this. Hey, did you know a cross join was used between these two tables, dv.policy and sys.snapshot on line 47? We give you the text, the SQL text. We give you the exact line where this occurred, and we're giving you a recommendation. Consider using an inner join instead. And just to illustrate this, we know some of the data up here, but bytes sent over the network, 39 billion, something along those lines. That probably attributed quite a bit to the cost and to the time related to the performance of this query. Food for thought. Okay, so now that we've been informed on what the state of the estate is, the health of our Snowflake environment, if you will, we've been informed on what we have opportunity to optimize and how to do that through thoughtful AI-driven insights and recommendations from the Unravel platform. But we can also automate this. We can wrap some governance around these processes in many different ways. So let's talk through two easy examples. I'm going to go to our operate, our govern section of our homepage here. So there's a few things going on here. Let me talk about the bottom half first. So integration into that development lifecycle. The way our CI/CD integration works, as an example, can be through GitHub Actions. So a developer would check in some piece of code. GitHub calls Unravel and brings in all of the recommendations. Unravel would see it. What are the inefficiencies, if any? Does this code have any inefficiencies? Yes or no? The developer would then make a choice, make a change based on the recommendation, and then move that code to production, mitigating issues down the line. This can also all be traced and tracked through ticketing platform integration with something like a ServiceNow. A developer also never necessarily needs to log into Unravel to benefit from Unravel. We meet them where they are used to working. Alerting, the top half of this screen. You can enable Unravel provided out-of-the-box alerts or create your own custom alerts. And we can start to develop and enforce good governance policy through alerting. So here's some examples. Queries that cost more than $100. This guy's disabled. Queries that ran longer than 80% of warehouse level timeout. This one's enabled. Hey, I have a simple use case. I want to create my own custom policy, right? My own custom alerting. Maybe there's a policy I want to set up at that Snowflake query level. There's been an influx of queries lately that cost $1,000 or more. I want to get to the bottom of it, or I want to track it. So I want to know when this is occurring. If it goes over that $1,000, I want to do something. I want to perform an action. That $1,000 price tag, that's my trigger. Now let's automatically perform some action, maybe through a notification channel, a post to Slack, a simple email to someone, create a ticket, or some other mechanism. So in summary, we covered best practices outlined by the FinOps Foundation. We showed how customers are applying these principles with out-of-the-box tools. And finally, how Unravel can make life easier for FinOps teams who want to operationalize these best practices at enterprise scale. Thank you.